So let's start the next example. So in this next example, what we can ask about is whether two surfaces that touch somewhere, if they're actually tangent at that place or if they just kind of cross through each other, right? So in this case, we're asking about the ellipsoid 3x squared plus 2y squared plus z squared equals 9, and the sphere x squared plus y squared plus z squared minus 8x minus 6y minus 8z plus 24 equals 0, if they're tangent at this point. Now, I've already kind of prearranged that this point is, of course, on both surfaces. Might be a good idea, in case you're skeptical, to take this and plug it into both equations and verify that, yes, they do, in fact, meet at that point. That means this is on both surfaces. But what we want to ask is, how do the surfaces touch there, right? So showing that they're tangent to each other there means the following, right? So we have an ellipsoid here, looks something like this. That's going to be a bad picture. Right. We have an ellipsoid, looks something like this, all right? And then we have a sphere, and the way we're asking that they meet is so they look like this. That's not a very good sphere, is it? Oh no, I've made things just worse. Let's try this again. Yeah? Maybe make it a little bit better. Well, not perfect, but better. So we're asking that they sort of just touch like that. So they just barely kiss each other, right? There's no actual crossing through each other. So how do we show that? Well, if you look at the way these two surfaces here meet, it looks like all of their tangent directions are the same. Like the tangent plane at these 2 points is the same. That's what it would mean for them to meet tangentially. Well, if their tangent planes are the same, then what is that? How can we say that in terms of vectors? What that means is that the gradient vectors, they don't have to be the same, but they have to be parallel to each other. So what that means is we should think of each of these each of these surfaces as a level surface, take the gradient and show that those two are parallel to each other. That's how we can show that it's tangent. And of course, if the gradients aren't parallel, then that means that the intersection is not tangent. Okay, so solution. So for the ellipsoid, we can think of this as a level set of the function f equals 3x squared plus 2y squared plus z squared, right? In particular, this is f equals 9, right? If the thing on the other side here is just a constant, then we don't have to worry about it. Because remember, a level surface is f equals a constant. So we don't have to move that over and set it equal to 0. You can, it would be perfectly acceptable though. All right? Now the sphere, this one will be given by g. Well, just take this whole thing here. X squared plus y squared plus z squared minus 8x minus 6y minus 8z plus 24. All right? And in this case, the sphere is g equals 0. And if you're wondering, yes, we can actually leave off the 24 here, but then g has to be negative 24, right? Okay, so now we take the gradients. So gradient of f is 6x, 4y, 2z, and then at 1, 1, 2, this is 6, 4, 4, right? Now let's do the same thing for gradient of g. Okay, so we have 2x minus 8, 2y minus 6, and 2z minus 8, right? And then at 1, 1, 2, this is the vector negative 6, -4 and -4. So are these two vectors parallel? The answer is yes, of course. How are these two parallel? Well, gradient of f at 1, 1, 2 is the negative of the gradient of g at 1, 1, 2. Right? If we multiply either one of these by -1, we get the other. So that means the gradients, they are parallel. And since the gradients are parallel, then the two surfaces are tangent. So the gradients parallel implies surfaces tangent. Okay? So that's how you can check. If you have a point where the two surfaces meet, in other words, a point on both surfaces, if their gradients are parallel at that point, then the surfaces are tangent at that point. Okay? Hope that made sense.